Thank you so much for the setup. And good morning, good afternoon. Uh, I know you all must be hungry, and we had a long session. It got extended, but that's fine. So we have been hearing regarding AI since the morning. So I thought of take you to a different journey. AI will work on what? So something has to be there to AI to work upon. So today I will be talking about crossing boundaries, unlocking platform channels in Flutter. So how many of you have at least worked on mobile technology or front-end technology? Wow, so many of you. Great to see. So at least I don't need to set the context. So my name is Suraj Kulkarni. I have total 8 years of experience. Currently, I am working with Cornerstone On Demand, a US-based multinational company which work on LMS. So I am working there as an Android developer. But apart from that, passionately, I work on Flutter as well as on Kotlin Multiplatform. So both of these are hybrid technologies. Those of you who don't know. So how many of you have actually worked on Flutter? Great. So no different introduction is required for the Flutter. Flutter is a cross-platform tool or cross-platform technology to write your application, write your code once, and then deploy it on any of the platforms. So currently, Flutter supports Android, iOS, web, Linux, Mac OS, and even on embedded systems. So they also support embedded systems now. So it's a front-end technology where you can write your code once, and the language which is used to write the Flutter is Dart language. So syntax is very similar to Java, and it has many APIs, and the Flutter is backed by Google. So they have very good documentation, very good community support, and there are people around who will help you if you get stuck anywhere. So there are few key pointers why I specifically choose Flutter as a technology to develop front-end apps. The first and foremost is what I'm going to talk about is the platform channel. So platform channels are something where you can communicate with the native platform. So suppose you have built your front-end app for Android, and then same code you want to run on iOS. But there is something which currently is supported by Apple, but the same thing is not available in Android. There are many things. Or maybe iOS or Apple scales fastly, or Apple has their own hardware, so they added something which Android doesn't have. So recently we have seen many features which Android had and Apple has released just now. So in such cases where you want to access the native APIs means suppose if you want to get the battery level, the very simple example, you want to show somewhere, you have an app where you want to show or you want to use if the battery of the device is less, and in the Flutter application you want to show the battery is draining or battery is low, please recharge. You want to show, there is some app where you want to show this message. Now the way battery level is handled by iOS is different, and the way it is handled by Android, it is different. Same thing goes with the camera. Mostly which are hardware related things, these are very different on mobiles for Android, iOS, or even if you go on the web also. So these things are very differently handled. So Flutter team thought, how can we tackle these? Because being Flutter being a hybrid platform, they wanted to make sure that our framework works very efficiently on all the platform without the need of changing the code, without adding the if-else ladder. They don't want to do this. So they introduce something called as platform channels. So platform channels helps you to call those APIs from Flutter code itself. So you have written some code, you want to check the battery, or you want to have the access of latitude, longitude. So how would you do that? So they have introduced something called as platform channels, where the way you call an API, the way you call an server API, similarly you can call the you can call over a platform channel. I will show you how to do that. You can call over the platform channel, and you can get the you can invoke the native API. So there is some API in the iOS which gives you battery level. You can call that function from the Flutter code, and you can do reverse also. There is something in the Flutter, and you want to access in the native code. So this usually is required when your whole application is native. Suppose you have been developing app from last 10 years, you have a big code base, but there is one screen where you have developed in the Flutter, only single screen, or you are planning to migrate from native to Flutter slowly because of its advantages. So you don't want to immediately, because it's not possible in 1 month or 1 year to migrate all the code and then release directly. That's not possible. So it has to be done slowly, screen by screen. First you will start, few new features you will add, and then slowly old features you will migrate to the Flutter thing. So in that case, when you develop one screen in Flutter and you want to have access of some native, or you have something in Flutter you want to access in the native, so that communication is established via the platform channels. So there are not only the platform channels, this is one of the way to access the native APIs, but there are other ways by which you can access the native functions or native classes, native objects. Another way is FFI gen and JNI gen. So this is nothing. We all know C++ code works on both, on iOS as well as Android. So you can write FFI gen and JNI gen code. Those objects or those classes you can directly access in the Flutter side. So that is another way of accessing the native calls or native code from the Flutter side. So basically there are two ways. One, so FFI gen you use for iOS, JNI gen you use for Android, and then the third way is invoking the platform channel. Then there are multiple ways. So I just don't want you to understand this over or the surface. I want you to get inside, look how actually it is done under the hood. So we'll just switch to the next slide. Yeah. So how it works under the hood. So this is the basic block diagram, how the custom Android code and custom iOS code is accessed by the Dart code. Yeah. So the way it works via the binary messages. So the first thing we need to understand, if you want to send some data, because without data, what is the point in calling the function? You need to send some data. So suppose you created a user object, you need to send. That is directly not possible in Flutter. What is possible? You can share primitive data types. So integer is there, string is there, float is there, long is there. There is a list of data types I will show you in the next slides, which you can only pass. And why that has to be done? Why cannot you directly directly pass the custom data type? Why you need to serialize and deserialize is that we will understand in the next slide, where I will explain how the platform channel worked under the hood and what is. So in the topic itself, I am talking about the boundary. So what is that boundary? I will explain. So here in this, so this is the Flutter engine for Android and Flutter engine for iOS. So yeah, if you see the architecture, this is the Flutter framework. Yeah. So this is the Flutter framework. This is common for all the platforms. This is the engine which is written in C++. This is also common for all the platforms, Android, iOS, web, Mac, Linux, anywhere. But if you see the embedder, which is platform specific, this is separate for every platform. So when you bundle your binaries, when you build your APK, IPA, or the binaries for the web, then this embedder goes along with this code. So framework goes into the APK, IPA, C++ goes into APK, IPA. Along with that, this platform-specific embedder goes. So now this platform-specific embedder is written for that particular platform. This is not common. And because of this, on top of this embedder, this code runs. So therefore, I usually in my talk say Flutter is not purely native. They brand it as a native platform. It runs natively. Yes, I agree that it runs natively, but it's not purely native, because whenever you build native APKs or native IPAs, those run natively directly on your hardware. But here there is a platform specific embedder. If this embedder is not there, this code won't execute. So you can say it is like a sandbox in which Flutter code runs. So on both the sides, so below this embedder, the native hardware is there. So when you pass any data through this embedder, the native side doesn't understand your custom object. So if you create user object, it will not understand. So this everything has to pass this embedder. But what native understand is primitive data type. So if you have strings, integers, and all those data types are understood by both the parties. Therefore, when you pass this layer, you have to convert from, you have to serialize your objects and deserialize if you want to pass, because of this platform specific embedder. So to seamlessly cross this platform specific embedder, Flutter has given you APIs, which are called as platform channels. So let us look at what are different types of platform channels. So there are different types of platform channels. All of them work on the binary messenger only. Under the hood, everything is binary messenger. So till now, what we have understood, how Flutter runs on, why Flutter is hybrid, how Flutter supports all the hybrid, all the platforms being written the code on the ones, just because the platform specific embedder is different for different platforms. But above that, the framework layer and other Dart APIs, those are common. So therefore, you write the APIs, you use those APIs to write your app, but this embedder is different. Therefore, it for different platforms, this embedder is different, and hence your code runs on top of that embedder. And hence, to communicate, you need something called as platform channel. You cannot directly invoke those APIs. So ultimately, these three different types of channels are there, and then all the channels use binary messenger itself under the hood. So just let's go through them one by one. So method channel is something used for, as the name suggests, when you want to invoke any method from native or the vice versa, you will just call the method channel and it will give you the response. Call the function, get the response. For asynchronous, so there is some API call written on the native side, and from Flutter you just want to invoke that API, you will call that function. When that processing is done, it will return you the response. So we will see the code as well. I have added the snippets, but for now just stay with me. So for any synchronous asynchronous communication, we need method channel. Then there is something called as event channel. So what is event channel? When you want to send some updates from the native side to the Flutter. For example, location update. So you have a driver app where driver is roaming through the city and you want to get the updates, and your app is developed in the Flutter. So your native code will send the location lat-long updates to the Flutter side, and Flutter will display his latitude, longitude, and the vehicle position. Same thing goes with the battery. And how many of you are Android developers, if there are any? Yeah, great. So all of you must be knowing about broadcast receivers. So system sends many broadcast messages every time. So if there is a message, it will send the broadcast. So if you have your code written in native and you want to listen to those broadcast messages, you have to use event channel. So whenever there is a broadcast, you can send that information to the Flutter side. Then there is something called as basic message channel. So in the basic message channel, used for sending a basic one-to-one communication. So there is here you can send normal text messages. So the difference between the basic message channel and the method channel is, in the basic message channel, you explicitly define what kind of data type you are going to send across the channel. So it helps in faster communication, because this involves some, not the user will never notice the delay when you send the data across the platform channel, but ultimately if you have a huge data, it will come to the performance side. So when you define what kind of data type you are going to send across the channel, then basic message channel gets useful because it is very faster. So if you just have a text data which you are sending to native and getting back, then basic message channel is the way to go. So these are 3 different types of platform channel. All of them work on the binary messenger only. I just spoke what kind of data types are supported. So you can see here so I have shown only for Kotlin. So if in Dart it's null, it's null. So all these types can be sent over the platform channel. So all these types are supported. But you can see there is no custom data type which you can send. So I have only added the screenshot for Kotlin language, but all these languages are supported. So if you have written your app in C, you can communicate over the method platform channels. So null is there, bool, integer, double, string, float, list and map. And you can always serialize and deserialize data and send it over the platform channels. One more important thing, platform channels are not type safe. So you may encounter the runtime crashes if you don't pass the correct data type and receive the correct data type. You send string and receive integer, your app will crash. And to counter this, there is a plugin which some community person has created, which is called as Pigeon. If you use the Pigeon, it will generate some code for you, and then you have to use that code into your app to stay away from the type safe errors. So you can check out the Pigeon plugin. So this is a very first example of method channel. So we talked about 3 different types: method channel, event channel, and basic message channel. So method channel. So this is the Flutter code where where I am trying to get the platform version. So on which Android version or which iOS version my app is running, I want to get that. So I just simply define the version, the channel name. So this is the name of the channel. You can give any name. The slash is not required. I have just written it for the simplicity. So you just create one channel, and then from using that channel you invoke the method, and this is the name of the method which is written on the native side. So we will see, so this is the Flutter code. Now we will see how this method is written on the other side of the page, which is the native side. So I am little bit biased here. So being an Android developer, I have written this Android code. So here also, this method so this is overridden function you get on the native side where you have written your Android code, and you need to override this method. And this is the engine which I was talking about. And you again see this binary messenger. And this is the constant which I have defined somewhere above in this class, and this is the same constant which we talked about in the previous slide, this method channel. So you have to give the same name, here, and write set method call handler. And you have seen I have written one function name. So the same function name, so if you have multiple functions, you can write the switch cases here, how many times you want to write, whatever you want to write, and then that particular code of block will get executed. Again, here you have 2 options. You can call a success or error. So there might be chances where API fails or native API is not able to respond. In that case, the error message will get called, and in case of success, the success will get called. And here from the Android side, I have written the version, the SDK version which my mobile is running currently. So this is how you invoke the native API. So this build.version.sdk int is a native. This is not available in iOS. iOS has a different way to get the iOS version. So this is the reverse. So I talked about reverse. So this is where you get the Flutter version. So you have native application, but you want to get the Flutter version. So this is written in the this is written on the Flutter side, where I am returning the Flutter value. Same. So here we have future.value and future.error, the way we had result.success and result.error. So this is the way you can call the reverse. And then moving on to the opposite side. So how you write the same, how you get that data on the native side. So this is the code for the Android side of, so you have sent the Flutter version, how will you get that Flutter version? In the success, this success overridden method will get called, and in this error, the error overridden method will get called. So I have the similar code for event channel, same, this is a stream of data, and I have received some broadcast, and I am listening and listening on the Flutter side and updating some variable. And how I am sending this data? So this send stream of data. So this continuously getting sent from native side to the Flutter side. So this is event channel. So just because we don't have much time and we are already running, so I will just run through the slides. So this is the example of basic message channel, where you will set up the basic message channel, and then you will handle the message from what message is coming from the native, you will display that, and you will return if you want to return the response. If you don't want, it's not mandatory to return something. Similarly, for reverse side, how you access whatever has been sent from the Flutter side on the native side. So this is from message from native. And these are just additional slide which I have added if we had the time regarding JNI gen and FFI gen. So I will just run through because we don't have much time. Yeah, so we'll move to the question and answers if you have any. I hope you have understood at least something from this session. That was the only aim which I had. I didn't want you to understand everything, but I want you to know what is the Flutter's platform channel and how Flutter's platform channel can help you when you are stuck on the natives on the Flutter side. If there is something where you which you does not understand, then please feel free to connect me after the session. I will help you to explain more. Yes, please.
Hello. Yeah.
Yes.
So basically, we are actually building a mobile application which connects with the smart touch switches.
Yes.
Right. And we also want to build some device which will be like used for tracking geolocation.
Yes.
So if I write the platform channel code, do I also need to write the invoke method on the Android as well as iOS side?
Yes. So you have to write invoke. You have to write invoke method only once, and on the platforms, on the native platforms, the respective method will get invoked. So you don't have to write two different blocks for iOS and Android. You just have to invoke method you have to call, you have to give the method name, and those method you need to implement on both the platforms. And for all of you hardly need, until and unless the use case which you have switchboard something, until unless you have such use cases, you don't need to write the platform channels, because the Flutter community has been have written many plugins which are already available. So geolocation plugin is already there. You just use that plugin, and you will get the updates from the native iOS and Android. Any more? Yes.
Hello, sir. My name is Abhijit Kaire, and I'm an Android developer.
Yes.
So my question is, I specialize in Kotlin.
Yes.
And is Flutter better than Kotlin multi-platform?
Yes, that's a very good question. There has been a lot of debate. So I must admit that when Kotlin multi-platform was not stable, I was in love with the Flutter. But now the Kotlin multi-platform has came. Flutter is there, it's stable, it's very good, community support is there, you can develop quick applications into the Flutter. Along with that, it supports your existing, you have already some code base and you want to develop a part into the, develop its part into the Flutter, that is also supported. But when you come to Kotlin multi-platform, it has another advantages. So both of these are, you can say, meant for different use cases. So if you have something where you want to start from scratch and you want to have a quick POC, you want to go to market, check market conditions and come back. And the main thing, you don't have many things which are related to hardware. You don't want to interact with hardware much. You just have to write the application layer. Then Flutter is the choice. And if you have already written code and you have too much interaction with the hardware, then Kotlin Multiplatform is way to go. So the thing Kotlin Multiplatform currently lags is it is in the last connect. It is also supported by Google, so the documentation, it will improve over the time. Community support is less. Plugins are not readily available. At times you need to write your own code. So those few things are not very good. And then UI is also not stable. So they are testing alpha, beta, they are doing. So if you want to write UI also in Kotlin Multiplatform, I will not support. But if you want to write UI and you have to write the application layer only, where you call the API and get the response, then Flutter is the way to go. I hope I answered your question. Yes? Flutter?
Second.
Yeah, Flutter fork has been created. Yes, so someone has, I heard that news, but then still the ownership is with the Google. We don't know what Google has planned for the Flutter as a ecosystem, but right now they are actively investing into the Flutter. I can see their team. So I also heard that Flutter, the Google team has laid off many developers from the Flutter. So like I cannot, I'm not the right person to comment on that. But then and then having one Flutter as a hybrid platform, again supporting the Kotlin multi-platform. So what are their intentions? I am not sure. But as of now, they are investing, and therefore I am standing here and talking about Flutter.